students, I am Ekta. Today we are going to learn the measure of central tendency. In the world of statistics, understanding the concept of central tendency is crucial for interpreting and analyzing data. It allows us to identify the typical or central value within a data set, making informed decisions and drawing meaningful conclusions. In the lesson, we will delve into three fundamental measures of central tendency: mean, average, median, middle value, and mode, most frequent value. These measures serve as essential tools for anyone seeking to make sense of data, whether in the context of academic, research, business, or everyday life. Learning outcomes. After the completion of this lesson, you will be able to understand mean, average, median, middle, mode, most frequent value. Keywords: mean, median, mode, cumulative frequency, average, observations, middle value, dataset. Now, we will see what is a measure of central tendency for ungrouped data. Measure of central tendency are fundamental statistical tools used to describe and understand the center or average of a data set. They help us find the typical or central value in a set of data points, which can be essential for making sense of information, making decisions, or identifying patterns. There are three primary measures of central tendency: mean, median, mode. Now, let us learn what is mean and how to find the mean of data set in detail. Mean, average. The mean is the most common measure of central tendency. It's calculated by adding up all the values in a data set and dividing by the total number of values. The mean provides a balance point or the arithmetic center of the data. It is denoted by X bar. X bar is equal to sum of all the observation by total number of observation is equal to x1 plus x2 plus x3 plus so on plus xn by n is equal to summation of I is equal to 1 to n xi by n. For an ungrouped frequency distribution, one can use this formula: mean X bar is equal to sum of all the observation by total number of observations is equal to summation of I is equal to 1 to n fi xi by summation of I is equal to 1 to n fi. Now, we will see how to find the mean of data set by solving an example. The following numbers of goals were scored by a team in a series of 10 matches. Solution: given the total number of matches n is equal to 10. We know mean x bar is equal to sum of all the observation by total number of observations. X bar is equal to x1 plus x2 plus x3 plus so on plus xn by n is equal to summation of I is equal to 1 to n xi by n. We know the value of n. Find the value of xi. Summation of I is equal to 1 to 10 xi is equal to 2 plus 3 plus 4 plus 5 plus 0 plus 1 plus 3 plus 3 plus 4 plus 3 is equal to 28. Now substitute the value of xi and n in the mean formula, then we get x bar is equal to 28 by 10 x bar is equal to 2.8. The mean x bar for the given data is equal to 2.8. Note: this method will be effective if the data set is small. Let us see another example. Find the mean of the marks obtained by 30 students of class 9 of a school are given in the table. Solution. The given table is an ungrouped frequency table. We can follow the previous method, but it will be tiresome as the data set is big. So, we will follow similar method to find the mean of the following data. First, multiply the marks column with students column, then we get Fi Xi. The sum of number of students Fi is equal to 30 and sum of Fi Xi is equal to 1779. We know the formula for mean of ungrouped frequency distribution table, that is mean x bar is equal to sum of all the observations by total number of observations. Summation of I is equal to 1 to n Fi Xi by summation of I is equal to 1 to n Fi. Now, add all the values of Fi Xi column to get the summation of Fi Xi. Now, substitute the values in the formula, then we get 1779 by 30 is equal to 59.3. Now, we will learn the median in detail. Median, middle value. The median is the middle value when data is arranged in ascending or descending order. or it is the value of the middlemost observation when arranged in order. The median of the ungrouped data is calculated as follows. When the number of observation n is odd, the median is the value of the n plus 1 by 2th observations. When the number of observations n is even, the median is the mean of the n by 2th and the n plus 1 by 2th observation. Let us see an example. The points scored by a Kabaddi team in a series of matches are as follows. Find the median of the point scored by the team. Solution. Arrange the points scored by the team in ascending order. We get here there are 16 terms, that is n is equal to 16 is an even number. So there are two middle terms, that is n by 2th and the n plus 1 by 2th, that is 16 by 2 and 16 plus 1 by 2. Is equal to 16 by 2 and 17 by 2. That is 8th and 9th term, those are 10 and 14 respectively. So the median is the mean of the values of the 8th and 9th term. Median is equal to 10 plus 14 by 2 is equal to 12. So the median point scored by the Kabaddi team is 12. Now let us see one more example. Centuries scored and number of cricketers in the world are given below. Find the median of the given data. Solution. To find the median, we need to arrange the frequency in ascending or descending order, then we can find the middle position of the data. But in this question, when the frequency added up, we get the total as 139. Now, we should write 5, 5, 5, 5 for 56 times and 10, 10, 10 for 23 times, and similarly we should write for all points. This is a huge data. To write them in ascending or descending order will be time consuming and there is a chance we might count wrong. So, we will go with cumulative frequency, that is running total of frequencies. Now, draw 3 columns, one for the number of centuries, another one for the number of cricketers and the last one for cumulative frequency. In first row of cumulative frequency, the value is same, that is 56. In second row of cumulative frequency, the value is 56 plus 23 is equal to 79. In third row of cumulative frequency, the value is 79 plus 39 is equal to 118. In fourth row of cumulative frequency, the value is 118 plus 13 is equal to 131. In fifth row of cumulative frequency, the value is 131 plus 8 is equal to 139. Now, the total frequency n is equal to 139, which is an odd number. The median for odd observations is equal to n plus 1 by tooth is equal to 139 plus 1 by tooth is equal to is equal to 140 by tooth is equal to 70th term. So, the median will be the number of centuries corresponding to cumulative frequency just greater or equal to 70, that is 10. Therefore, the median is 10. Now, let us learn the mode in detail. Mode, most frequent value. The mode represents the value that appears most frequently in the dataset, that is, an observation with the maximum frequency is called mode. Now, let us see one example. Find the mode of 14, 25, 14, 28, 18, 17, 18, 14, 23, 22, 14, 18. Solution. First, we arrange this data in the following form. Here, 14 occurs most frequently, that is 4 times. So, the mode is 14. Now, let us see another example. In a science test given to 15 students, the following marks out of 100 are recorded. Solution. First, we arrange this data in the following form. Here, 52 occurs most frequently, that is 3 times. So, the mode is 52. Students, let us summarize what we have learned. Mean. It is found by adding up all the values in a data set and dividing by the total number of values. X bar is equal to sum of all the observation by total number of observations is equal to summation of I is equal to 1 to n xi by n. For an ungrouped frequency distribution mean, x bar is equal to summation of I is equal to 1 to n fi xi by summation of I is equal to 1 to n fi. Median. It is the value of the middlemost observations. If n is an odd number, the median is equal to value of the n plus 1 by tooth observation. If n is an even number, the median is equal to mean of the values of the n by tooth and n plus 1 by tooth observations. Mode. The mode is the most frequently occurring observation. Thanks for watching this video.